So the time has arrived, and it's now time to basically, take it to a real quantum computer and see what happens. Let me just restart the whole thing in here, restart, and run the whole thing. Now, two things I gotta do. First, I'm gonna try to understand which quantum computer they used in their experiments. Okay, so first of all, I'll just I think go to one screen and zoom that in. So experiments on IBM Q devices. 5 physical qubits corresponding between qubits, get fidelity. Where are all those things taken from? That's They'll be curious. Okay, so these results show that IBM Q Valentia is a better device than IBM Q Orense in accordance with their QV values in terms of average fidelity and variance. So are we going to try with the Orense? Or, yeah, both Orense and Valentia. Okay, so we can try with both for these and also for the 4 qubits. Now, the question is, do I have those available for me? I don't know. So now I'm going to take a look at this one here. Melbourne has 15 qubits online. Burlington Orense has 5 qubits, and there's just one job in the queue. So that's like, yeah, sounds like cool. But there's no. Okay, so Orense is there, so at least the same machine is there, but not Valentia. So now, how do I do this? So I think I gotta basically, in the textbook, there is a nice introduction to this, I think, on how to set it up, and I might have to pause the video just so you don't see my API key or whatever secret that needs to be put in there. Let's scroll down. Accessing a real quantum hardware. So back in objects contained in a new package, assuming the credentials are already loaded into your computer, you sign in with no credential on. Okay, so this regards to sign. Okay, that's a separate. Okay, so this is the documentation. Install. This is not access IBM Q systems. Create a free IBM Q systems account. I got it. Navigate to my account and to view your account settings. Okay, so I'm gonna basically, just in case I don't want anything here to be seen, so I'm gonna probably save it in a file and whatnot, and do some of the things in here. So I'm gonna pause for a second, but you just won't notice. Okay, so give me 1 minute. So I think it's that. Let me just try it out here at the end. So let me just try and do this first. See if that loads. Error. I think it's not defined. I gotta import that as well. So give me a second. I'm missing an import. That should work. So and now those instructions should basically load my account and provider. Give me a second. I think I copy pasted the wrong. Okay, so that should be that should work. Yeah, I just was putting this in a notebook temporarily, so it's fairly easy. Just follow the instructions and the Qiskit textbook, and then in the guide here, in the field documentation, it's pretty straightforward. So these are all the devices that we've got available now. Okay, cool. Now, how do I? So in theory, I should just be able to get a backend the way that I'm just real backend. So I would say real backend, IRKit backend. And can I just call it like this and say IBM Q Orense? Like, is this how this works? R is not defined. Do I need to? To import absolutely everything again. Let's wait until everything is rendered. Everything pops up here. Now let's get the real backend. Credential already used. Backend not found. Isn't that how I do this then? More than one backend matches the criteria. Get backend IBM or and say, how do we? So, okay, so let me backend print backend status. Provider get backend. Provider. So I should use not IR. I should use provider. So IR is just what provides the simulators. I get it. So this gives me the real backend, the provider, which is the IBM Q. Get provider, the IBM Q as a provider. Okay, cool. Am I expecting something as an output? I would assume so. Now the trick here is, how does this look like in terms of connectivity? Do I have to modify anything in my device? Machine mapping. So this is an example mapping. How do I know? So when anyone can embed in all recent processes, including the 5Q processor IBM Q, Vigo or Rensis. Similarly, when n equals 8 or less, we can embed in the processes IBM Q, WebLink Singapore, which have 20 qubits, but I don't have access to them. Okay, so experiments on the IBM Q devices. With a proposed algorithm by finding Max Scott. Can I find here somewhere the connectivity? I mean, I can probably just. Okay, I can just probably. I think there's a way to read that. Yeah, properties, the coupling map. So if I do this, real device, real backend, and if I now, can I now print the coupling map? Print the coupling map. So 0 to 1, 1 to 0, 1 to 2, 1 to 3, 2 to 1, 3 to 1, 3 to 4, 4 to 3. This is the connectivity of the qubits, I guess. So qubits 0 and 1 are connected, 1 and 2 are connected, but 2 and 3 are not connected. Okay. 3, 4, and 4, 3 are connected. 1, 3. So 0, 1, 1, 3, and 3, 4. 0, 1, 1, 3. So that's, I think that's this one basically, right? Okay, so this is used as in Scylla qubit. How do I do this now? I can just I just run that, or should I map? Can I map the qubits, or like how or should I adapt the algorithm? So basically, Q0, Q1, Q2, Q3 are my data, and then Q4 is my ancilla. So I should probably change all those bits and pieces in here. It doesn't matter because actually these are all things that I put into instructions, and so the final test is just these, and then how I put things together. So I just need to change that. Actually, I just need to change the final test, a real device test. So I'm going to do So I'm gonna do a I'm a bit lost, so give me a second. So I'm gonna basically start here. So I'm gonna say, okay, so I'm gonna say this is not the final test, this is the real test. Real test. And so I'm gonna use, okay, so I'm gonna use these basically. This means that this means that, so 0, 1, 1, 0, 1, 2. Should I draw this? So 0, 1, 1, 0, 1, 2, 1, 3, 2, 1, 3, 1, 3, 4, and 4, 3. So I should use, okay, yeah, so qubit 1, okay, so qubit 1 should be the ancilla. I think so. Because then I can implement the Toffoli gate then starting from qubit 4. Okay. Actually, in the paper they've used, it's the same structure here. So okay, so they've used these as data 0, data 1, data 2, data 3. Yeah. But is it then qubit 0, qubit 1, qubit 2, and qubit 3? So qubit 1, I thought that would be the ancilla. Data 0, data 1. I'm a bit lost for a second. So we've got here. So this is how it's going to look like. So the ancilla qubit. I'm not so sure if this mapping is going to work, the ancilla qubit being this one, because then it means that that means I can, as I said, that means I can implement the Toffoli gate like that. Yeah. Okay. So, but then I should kind of starting by kind of saying that this is vertex vertex 0, vertex 1. I don't know, let's just do something. So so I'm gonna say qubit 1 is the ancilla. I'm gonna go with these. Let's see. Okay, qubit 1 is the ancilla. This is the ancilla. So this means I'm gonna Hadamard 0, 2, 3, and 4 as our data qubits. Okay. Then I'm gonna do, so now we've done the Hadamard thingy here, and then we're doing all that, right? So the actual circuit in here. So I'm gonna replace all these tests with real tests. With real tests, I'm gonna say, okay, so first is the oracle. So now the oracle, all the oracle should run on just the data qubits. So I'm gonna do these. I'm gonna do these. I'm gonna do these. Exactly. And now the amplitude amplification. So in the amplitude amplification, basically, the four is the ancilla qubit. So the last one is the ancilla qubit. So then Yeah, the rest I really don't care, right? Should work all fine. So I don't know. It's a weird. So here I should just say basically these and one. So, but how does this look like if I now do real test, draw, output equals MPL. So that's my Ancilla qubit. Okay. Mm-hmm. Yeah. But I'm not so sure if the amplitude implication I shouldn't just say 0, 2, 3, 4. So I should just say let's just try it. I mean, what can go wrong, right? It's just a real device. And so what? And now and now I just do execute. Do I just do it like this? I just do real job, execute, final test, real test, in real backend, and I'll just say 1024 shots. Now, before I run that, so if I go here to home, then and I go to Orense. Oh, here I can see the coupling and all this kind of stuff. Okay, so I nailed it. So if I now run this, what's going to happen? Hopefully, it's not going to break. Yeah, 2 jobs. Ooh, that's nice. So I guess I'm the second job in here. Nice. Let's see how long this takes, actually. I mean, if it's gone into the queue, does it mean that it's already for sure gonna run, or can it still just come back with errors? That's an interesting thing. I'll pause that now and then just wait, and then as soon as this gets done, I'll let you know, because I think that's really these. I mean, I don't know. This shouldn't matter the order of the qubits in here, because as long as the Ancilla is the right one, because the rest is it's really a multi-control Z what we're doing inside. So it doesn't really matter which qubit is the target, which qubit is the target, which qubit is the target, which qubit is the a control. It's just the ancillary qubit should be at least should be known, right? The rest shouldn't really matter. So, but I guess depending on what you're doing in here, you have to be careful. You have to have the right mapping, I'd say. Okay, so did this anyhow get updated? 2 jobs still. What was the job before me, man? Cannot be that. Cool. Yeah, I guess I'll just pause here and wait a little bit. Just realized there's one which has 0 jobs, so I just might as well try that Burlington as well. So I'll just try that device. It has the same amount of qubits, so I'll just do real job 2 and real backend 2, and so real backend 2 is going to be provider get backend. And what's it called? Burlington. I think you Burlington. Burlington. Burlington, correct? Burlington. So this is real test and real backend 2. Same as well. Just to see what happens, because I've been waiting for a while now already. So Now there should be a job appearing here. So same coupling. Same coupling. Orense still has 2 jobs. And this one here. So how can I check the status of a job? Can I expect result? Can I check the status of a job? Qiskit check job status. It's not getting any job? Yeah, now it's got a job. So hopefully it's mine already being executed. It shouldn't be long, come on. Because in Orense we still got another one before us running. So this is still there. And so how do I check job status? No. How do I check the job status? Status, simply real job 2. Train real job 2 status. And ooh, what about the job status? Is it still waiting? Done as well. Okay, maybe there's an error. Now, let's see if I get from job 2 the. I'm just job results get counts. Okay, so okay. The hist2 equals real job. Okay. I'm so bad at remembering this. Result get counts. Print hist2 data here. Interesting. How do I know there's been any error? If I do hist3, I'm really good at naming. Real job 2, get counts, and then print hist3 as well. Same. That doesn't look good. How do I know? Oh, I haven't added the measurements. Oh, awesome. So now we'll add the measurements for the real test, and it's going to be 0, 2, 3, 4, the ones that we're going to measure. 0, 2, 3, 4, 0, 0, 1, 2, 3 of the classical ones. Yes, we're not measuring the ancilla qubit. Oh my god. Okay, so how does it look like here? Is it still like that? I think they should still be like fairly empty, right? So I'll just shoot at both. Burlington is empty, and Orense has 2 jobs. I don't know. This doesn't have to be mine, but so I'll basically do that again. So we're getting them into both, and then so if I print the status, this is running. It's running. It's just running right away because it doesn't mean so the jobs in the queue. It doesn't mean they've got to wait until the one before finishes or something. Running. Okay, so at least it's not done. Oh, that's done. Real job's done. Real job's done, and this one should be also done. Yes. Please. Interesting. Oh my god. Ooh, let's see. And now, if I just say plot histogram, and I say hist2, hist3, again, awesome namings, color. I think I can do that. So I think I can say blue, I can say red, and I can say green. Does this work? Oh yeah. But it's quite underwhelming. Those things don't seem to have worked out at all. And the probabilities are not. They're fairly equal for everything. So I either mess up with the pairing. What does the paper look like? No, they should be fairly okay. Okay. They use a different. See, they use a different theta. They use a different theta, but I don't know if. So I'm guessing this might have to be. So let me just plot histogram 3, for example. Color. That doesn't look good. So again, maybe the order really matters. We're able to run it, so there's no kind of error in terms of coupling is not possible or not. But the could it be that this is could it be that this is could it be that the way that I map them is then not correct? So I basically said so the final target is Q. The final target is 3, right? The final target is 3. If but again, that shouldn't really matter. But let's assume it does matter. So the target is Q3. The target of the multi-control target is 3. Maybe it does matter because of the swaps in here, you know? Yeah. It does matter because of the swaps. It does matter because this has these swaps in here. So the target is Q3. If the target is Q3, then it means, you know, if that's the mapping and I'm doing like, okay, so I should probably, okay, so this should be then 4. So my target is the, let's rephrase that. My target is kind of 0, 1, 2 is the input Q3 in that. So I should do something like 0, 2, or 4, 3, then the ancilla qubit. It shouldn't matter for the rest of the algorithm, should it? 0, 2, 3, 4, 0, 2, 3, 4. No, but I could do 4-3, 4-3-2-1. I could do. I don't think this matters. But I could do 4-3-2-0, and then say the oracle is also 4-3-2-0, and then say now it should be 4-3. 2-0-1, right? 4-3-2-0-1, because 4-3 that's in qubit. 4-3-2-0, and then 1 is the ancilla qubit. Yeah, okay. So that should, maybe that works. I don't know. Maybe that works. 0, 1, 2, 3. Those are the classical ones. So I'm going to take these here. I'm going to take this here. Tricky. I think that's a bit tricky how this is defined. It's difficult. This is quite difficult. It's quite easy to make mistakes, I think, because you don't really know for those black boxes what really matters, what doesn't really matter. Because here I know the last input, and I'm assuming that I'm starting from Q0, but the last input is the ancilla qubit. That's what I'm assuming here. So that should be qubit number 1 in the machine, the real machine. That should be qubit number 1 in the real machine. Because then I can do yeah, let's see. So I've changed that. And now this. So now it's just a matter of waiting. Get the job results. Validating queued. Good. Okay, it's queued. So now there were some people squeezed in front of me. Burlington. So, and Arens is quite full. Running, and that's still queued. Okay, so job 2 is going to finish early, probably. Running should be done. Still queued. Okay, so but his 3 should be there. Maybe I should change that, add it into a new cell. Because otherwise it's not going to finish. Oh, am I having some internet issues? No, should be fine. Why is this not working? Still thinking. Might be having some internet issues. Let me stop for a second and check it out. Oh, seems all good. Status is done. So I just commented this out. Those things don't print right now, so Good. I mean, at least I managed to run something. That's good news. Come on. Really? What's going on? Okay, something's off in here. Um, I'll try to restart these and see what happens. But maybe, I'm having the hope that this works now. Otherwise, I'll have to leave it here and go on for the next video. But I mean, the idea would be this. I'm just gonna wait a little bit more. But so I would then be able to get these graphs with these plots in here, sort of. Orense with 0.25 art of x, art of m. Still not the best, but here you've got, yeah, with 0.32, 0.32. Okay. So they should be able to get something like that. And then, I mean, there's already acknowledgements, and then there's a bunch of stuff in here that I want to just go through. And performance of RTOFs, like it's just, I think, out of interest. I mean, I'm not so sure if I'm going to dig into this completely or try to reproduce those. Those seem to be the how's it called, the matrices, man. Or how they're called, the density matrices, exactly. So and then okay, this experiment dates and times. It would be interesting, but I think that's kind of that was what I wanted to do, is to kind of recreate those plots, at least for the K14. And then I'll go back and dig into the open questions that I left, like quantum volume and all this kind of stuff. Is this working or not? It's still not working. Okay, I'll just pause for a second. I'll just restart the whole thing and then give it another try. Okay. Okay, so I'm back here now. I'm gonna get, so this has been executed. So I'm gonna just execute on. I'm not gonna execute on this. I'm gonna execute just the real backend. Barlington is still empty, so I'm gonna do this. Good. Now I'm gonna print the status. It's running. Perfect. Perfect. It's running. So let's hope that works. Now it's still running. It's still running. I'm impatient. It's still running. I'm impatient. It's still running. Okay, let's wait a couple seconds, a couple minutes. It's honestly, it's pretty cool. I mean, I have to admit, it's pretty cool. You can actually use real machines. Fun. The histogram data. Let's print it. And let's see what that plot looks like. Yeah, the same. Okay, so I must be doing something wrong. I definitely must be doing something wrong in here. This is nothing to do with what I would expect. And I haven't forgotten to measure. The ancilla qubit is this one. And that the order here shouldn't really matter, honestly. Each qubit represents, like, the order shouldn't matter. Like if I run, let me do something. So let me just run the same thing on the simulator. I can just do it like that. So I'll just do, let me just run just to test run the real test of real sim, the simulator. It's the amount of maybe it's the amount of shots. And now get result. Okay, so basically go on the simulator. but this is the name of the job. And now plug for these data. I'm getting the right thing. What if I do 1024, which is exactly what I did with the real devices. So the exact same circuit works on a simulator, but it doesn't work on the quantum computer at all. The exact, right? And now I'm executing a real test. I'm executing the same type of mappings in here. How can that be? How can that be? Good. So that's, I think, an investigation task for the next video. Same circuit runs both on simulator and quantum computer, but it doesn't work at all in the quantum computer. It was pretty neatly in the simulator. Okay, good. Anyway, I tried. It was exciting, nevertheless. Good. I'll see if I can figure it out. If not, I'll probably ask for some help in the Qiski community. Let's see.